Why magnetic? Magnetic storage media and devices store data in the form of tiny magnetized dots. These dots are created, read, and erased using magnetic fields created by very tiny electromagnets. In the case of magnetic tape, the dots are arranged along the length of a long plastic strip which has been coated with a magnetizable layer. Audio and video tapes use a similar technology. In the case of magnetic disks, e.g. floppy disk or hard drive, the dots are arranged in circles on the surface of a plastic, metal, or glass disk that has a magnetizable coating. How magnetic working inside the computer.
Here we go. So a hard drive, the main components of a hard drive, you've got the case, that sits on the outside, that protects all the components and holds them in place, usually made of metal. And on there, on the case, we have a controller. And what the controller does is it talks to the CPU, and whenever the CPU, the rest of the computer, needs some information, needs to have a reading from the hard drive or writing to the hard drive, then the controller will send the electrical signals off to the rest of the components to do that. There we go, and you can see the little wires there that run along. Okay, so we've got the controller. Then attached to the controller is a spindle motor, and the spindle motor spins the disk platter. It controls how fast it spins. It normally spins, depending on what type of hard disk you've got, it will spin at about 7,200 RPM, revolutions per minute, which works out at about 120 times per second. So this is spinning pretty quickly. And what happens is, as that spins, you also have an actuator, which is another motor, and this actuator controls the actuator arm. And there you can see is the actuator arm. And as the disk spins, the arm moves to the portion of the disk where it needs to read from next. And when it gets to that point, the job of reading and writing is done by the read-write head, which sits right on the end. It doesn't look yellow and it doesn't look like that. It's actually incredibly tiny, but it sits right on the end of the actuator arm, and it's a little sort of electromagnet that can be used, and it can either be used in one of two ways. It can either be used to read or it can be used to write. Okay, so let's have a look at what's going on that platter with the head. So first, let's have a look at read mode. So as we said before, we've got the surface of the platter, and the surface is coated in tiny little regions of ferromagnetic material, and each of these little regions, these little parts here, can be polarized north or south, which is the equivalent to a 1 or 0 with data being stored. So you've got this data stored on the platter itself, and then you've got the actuator arm here, and it moves across the surface of the platter, and as it moves across, the read-write head goes across each of these sections, these segments. And as it gets to a polarized segment, what it does is a tiny little current, either a positive or a negative current flowing one way or another, is generated due to the magnetism here affecting the coil, and it sends a tiny little current which is then read by the controller, and that determines whether it is reading a 1 or a 0. And it just does that incredibly quickly, and you can see it here. As it goes over the blue ones, it's recording and picking up a 0, and as it moves over the red sections, it will pick up a 1. There we go. So that's how the read mode works. Really quite simple. Obviously, there's all sorts of things that can go wrong. There's interference, corruption, and those sorts of things. And advances in hard drives have allowed us to be able to read quite accurately using a lot of different techniques. Okay, so that's read mode. It just reads, it creates a little signal and it sends it down the actuator arm, which is red. So what about write mode? What's happening there? Well, write mode, it's pretty similar actually. You've still got the platter, the actuator arm is spinning. But all that happens is anytime the computer wants to write data to the disk, to any particular section, all it does is it sends a tiny little current along the coil, which is just enough current to be able to flip the polarity of the section that it wants to change. And again, it's doing this incredibly quickly, reading and writing as it's going through, depending on which segments need to be read or written. There we go. So that's how magnetic hard drives work. Obviously, as hard drives have increased in capacity, we need to store more and more data. And one way they've achieved that is what they did is, instead of just having a single platter and a single actuator arm, with modern hard drives, a lot of the time we stack multiple platters with actuator arms on top of each other. Which means that, you have twice as many platters, you get twice as much storage of data. And in this case here, you can store 4 times as much data. There you go. Okay, so let's have a quick review.
Review. Data is contained on a platter that is coated with a ferromagnetic material that can be magnetically polarized north or south. When the read-write head moves the surface of the disk, the data can either be read through measuring the magnetic field or written by sending an electrical signal through the head. Advantages and disadvantages. Advantages. They have a high storage capacity. They are relatively cheap. They are reliable. Data can be solved up 20 years. Disadvantages. They are quite heavy. They can be easily damaged if dropped. They use more energy than SSD storage because of their moving parts. Slower than SSD drives.